Now, draw the projections of a line capital PQ and find its apparent length, true length and true inclination with HP. When the line capital PQ has its end P 25 mm above HP and 20 mm in front of VP. The distance between the end projectors of the line when measured parallel to the line of intersection of HP and VP is 60 mm. The NQ is 50 mm above HP and the line is inclined at 30 degrees to VP. Now, so here the end Q, when the end P is 25 mm above HP and 20 mm in front of VP. So end P is 25 mm above HP. When you measure this distance, when you project this point, which will be lies on VP, so that distance above HP will be 25 mm. So you mark this point as P dash. Similarly, 20 mm in front of VP, when you look from the top view, the NP is 20 mm in front of VP. When it is projected, that point will be the point will lies on, the image will going to be lies on HP. So the distance will be 20 mm in front of VP. So you're going to get this point small p. Now, similarly, the end Q is 50 mm above HP. So here from XY line you measure end Q, which is 50 mm above HP, and draw a horizontal dash dot line, so which will going to be the locus of Q in the front view. So now the distance between the end projectors of the line when measured parallel to the line of intersection of HP and VP is 60 mm. So from the front view you measure the distance here, that is projector P, you measure the distance of 60 mm and draw a vertical projector so that it will going to cut the locus of Q in the front view. So this point will going to become Q dash. Then join P dash to Q dash with a dot line. So you are going to get this line. And then we draw the vertical projector in the top view, because the distance between the end projectors in front view and top view will going to lie on the same line. So that means the top view of the Q must lie on the same line. But now we got only the front view. We need to find out the top view and also the true length has to be found out, and true length in with respect to the HP also we need to find out. So now we know that here the line is inclined at 30 degrees to VP. Since the line is inclined at 30 degrees to VP, so actually he has given the true inclination line. So the true, but we don't know the true length, but also we don't know the locus of Q in the top view. We have to find out. So we have to find out this the locus of Q in the top view. We need to find out that. So but we have the true inclination with respect to VP. So that means the true inclination with respect to VP means it should be the true length will lie on the horizontal plane. If the line has to if the true length of the line has to be in HP, so that line has to be parallel to HP. So if you want to get the true length in HP, so you have to have a line which is inclined to HP. Which is the line which is inclined to HP? That is P dash Q dash is the line which is inclined to HP. You make that line parallel to HP. When you make that P dash with center, you take P dash Q dash as the radius, you draw an arc such that it will be made parallel to HP. When you make that line parallel to HP, when it is projected here, so you will go to get this on the XY line, and then from here you draw a vertical projector to the top view. But now we want, so on this projector you will going to get the end point of the true length. So the end point of the true length you will be able to get here, because the true inclination with respect to VP is given. So from P, by using the protractor, you measure an angle of 30 degree and draw this inclined line, so that it will going to cut this end projector here, so that you will going to get the point here. You mark this point as Q2, then draw the locus of Q here. Once you get the locus of Q, you will going to get small q2 here. So this is the line which is parallel to true length in HP. So that line has to be parallel to HP, which is P dash Q dash. So that is when you are projecting here, both P and Q2 will be above HP by 25 mm. So this is the true length in HP. Now, so now we need to find out the top view. To find out the top view, now we have the so we got the we got the true length here. Once you get the true length, now we have got the locus. Since we know this the end projector point, which is going to lie on this line, and now the top view also in the end projector, which is going to lie on this line. So then you draw a projector so that it will going to cut the locus of Q here. So you will going to get this small PQ. So here join small PQ with a dark line, which will going to be the top view. So to find out the true length in VP, you make the top view line parallel. So to make the line parallel with P as center, you take the radius of PQ and draw an arc such that you will going to make this parallel to VP. That is, P is in front of VP by 20 mm and Q1 is also in front of VP by 20 mm. And then we are projecting this, and when you are projected this vertically up, so that it will going to cut the locus of Q in the front view here. So this point we will going to get this Q1 dash, then join P dash to Q1 dash with little bit darker than the projector line. So that will going to be the true length, because this PQ1 is parallel to VP. So we are going to write capital Q1 here. So here this is the line which is the true length in VP, because the line is parallel to VP. This is the line which is true length in HP, because this is parallel to HP. So when you are doing this, when you are rotating in space, actually we are rotating from P to Q such that make PQ to Q parallel, so that this is the direction of rotation. Similarly, when you want to find out the true length in VP, you make this line parallel to VP with P as center. You take the radius of PQ and draw an arc such that it will going to become Q1 will also in front of VP by 20 mm. So when you are rotating like this, what here will going to be the image will going to be rotated. The image will be rotated in HP. It will going to be parallel to VP. That is, PQ1 will be parallel to VP. So this is how we will be able to, this line, this capital P and Q is the actual line you are going to get. When it is projected into the top view, you are going to get small PQ here, and when you are projected into the front view, you are going to get P dash Q dash here. So this is how you will be able to analyze this problem in 3D. Now we want to do it in 2 dimension in the sketchbook. First you draw the XY line and mark VP and HP. So NP is 25 mm above HP and 20 mm in front of VP. So above HP is seen in the vertical plane, which is above XY line. From XY line you measure 25 mm and draw a horizontal line. Similarly, in front of VP by 20 mm, from XY line you measure 20 mm below HP, below XY line, and you draw the horizontal line. Consider any point and then draw a vertical projector so that it will going to cut at this point, which is P dash, and at this point, which will be small p. Then the distance above HP is 50 mm. So from XY line you measure 50 mm above XY line and draw a dashed dot line, which will going to be the locus of Q in the front view. And we know the distance between the end projectors, which will going to cut both in the front view and as well as the top view on the locus. So the locus of Q in the front view is here. So when it is being projected, so it will going to cut the locus here. So this point will going to become Q dash and join P dash Q dash with a dark line. So you got this now. Now we need to find out the true length in the horizontal plane. Why? Because the true length in the horizontal plane is the one which will going to be found out, because we know the true inclination with respect to HP. That is, the true inclination with respect to VP, we know that image will going to fall on HP. So that means the true length we can find out in horizontal plane. To find out the true length in the horizontal plane, make the line which is inclined to HP. So which is the line which is inclined to HP? If you P dash Q dash. With P dash as center, take the radius of P dash Q dash and draw an arc by using the compass such that P dash is above HP by 25 mm and Q1 dash is also above HP by 25 mm. You make that line parallel to HP. Once you make that line parallel to HP, you will going to find the true length in HP. So then from Q1 dash you draw a vertical projector to the top view, and then since we don't know the true length, but we have know the true inclination with respect to VP. So from P By using the protractor, you measure an angle of 30 degrees and you draw this line so that it will going to cut the locus of, it will going to cut this vertical projector at this point. You mark this point as Q1. Since this P dash Q1 dash is parallel to HP, so you are getting the true length here. You mark this as capital P and capital Q and draw a dash dot line here. So write the locus of Q here. So you got this. Now, since the distance between the end projectors is known, so naturally the distance between the end projectors in the top view will going to cut the locus here. You mark that point as Q and join P and Q with a dark line here. So this will going to be the top view. Now we need to find the true length in vertical plane. To make this PQ line, it should be parallel to VP. If P is in front of VP by 20 mm and Q2 should also be in front of VP by 20 mm. With P as center, take the radius of PQ and draw an arc such that PQ2 will be parallel to VP by 20 mm. Then from Q2 you draw a projector such that it will going to cut the locus of Q in the front view here. Then mark that point as Q2 dash. Since PQ2 is lying parallel to VP, so this will going to be the true length. So you mark this as capital P and mark this as capital Q. So join P dash and Q2 dash with little bit darker than the projector line. So you are going to measure the angle with respect to this, which is going to be theta, and we know to measure the length, which will be true length, and measure the apparent length he has given. To find out the apparent length, measure P dash Q dash and PQ. So by using the scale, you measure the true length of this line, which will going to be 75.05 when you are doing it in computer. When you are doing it in manual, it will be 75. By using the protractor, you measure an angle of true length with respect, true inclination with respect to HP, which will be theta, which will going to be measured as 19.46 when you are doing it in CAD. When you are doing it in manual, it will be 19 degree. Then by using the scale, you measure the length of P dash Q dash, which will going to be the front view, which will be 65, both in CAD and as well as in manual. And you measure the apparent length of PQ in the top view, which will going to be 70.77 when you are doing it in computer. When you are doing it in manual, it will be 71. So this is how we will be able to find the solution. So now the same thing which can be explained in the step by step. So first we have taken distance above HP and in front of VP. Then we know the distance above HP and you drawn this locus. Then from here you know the distance between the end projectors when you draw, so that it will going to cut the locus here. You will go to you go to get the front view, which is P dash Q dash. If P dash is center, take the radius of P dash Q dash and make it that line parallel to HP. So you will go to get Q1 dash, and then draw a vertical projector from here because we don't have the locus, but we know the true inclination with respect to VP. So since the true inclination with respect to VP is known, from this point you measure an angle of 30 degree and draw this line, which will going to cut this end projector here. It is going to become Q1 because P dash Q1 dash is parallel to HP. So you are getting the true length in HP. So you mark this as capital P and capital Q, and then draw a horizontal dash dot line. So since we know the end projector, so you are going to cut this here. So you mark this point as Q. So that is been explained in the second slide here. So here it becomes PQ. So once you get this PQ, then rotate this, make it parallel to VP. So you make this line parallel to VP. The PQ2 dash is parallel to VP. So once you make PQ2 is parallel to VP, then when it is projected onto the front view, you will going to get cut the locus of Q at this point. Since PQ2 is parallel to VP, so you are getting the true length here. You mark this as capital Q and mark this as capital P, and then join this with little bit darker than the true projector. So you will measure the angle theta, and you will want to also measure the top view line. So this is how we will be able to solve this problem. Even in the stepwise also we have explained which one has to be taken first and which one has to be taken second. So this is the process in which we will be able to find the solutions. Accordingly also we have shown this in 3D also. So when the top view line is rotated, made that parallel, you are going to get the true length in the front view or parallel to VP. So this is the final solution for this problem.